Hello everyone. Today's problem is solving questions with Brainpower. So let's see what is the problem. So we are given a zero index 2D integer array, questions, and each question denotes a pair of points and Brainpower. So here I denotes the ith index. So for example, if you see this is one question, this is another. So there are a few questions in the exam and you cannot attempt all of those. You have to make a choice to maximize the points. So the first number in the tuple is points and your goal is to maximize that, and the second denotes brain power. So it works like if you solve this first question you get 3 points, but this brain power 2 means that you have to take rest for next 2 questions. So if you solve first, you cannot solve the next 2 because brain power required is 2. If it were 3, then you would not have solved this third also. But you can solve this one because you have skipped 2. So now if you solve this, you will get 2 more points. So you will get 5 points. So your goal is to solve those questions which maximize the points. So other possibility could have been that I skipped this first question, so did not solve first question, then I can solve second question. So I get 4 points, but here the brain power is 3, so I cannot solve next 3. In fact, there are 2 only, so you get total 4 points. So in first strategy, our points was more. Next strategy can be, so first was this. So this yielded 5, this yielded 4. Next can be that I don't solve first 2, then solve third and don't solve fourth. So I get 4, and the other one can be just solving the last. But why would you solve last? You can additionally add first. So these are 3 cases and the maximum is 5. But we cannot do this kind of brute force approach. So if there are n questions, for each question we will either say 0 or 1, solve or not solve, solve or not solve. So there are 2 possibilities for each. So you will end up having 2 raised to the power of n combination possibilities, and that would be exponential. So our goal would be to solve in somewhat linear kind of time. Can we do it in that fashion or not? So let's see. So think in terms of dynamic programming approach. So can we break this problem? So what if I know the answer for till some part of the question and we are building on top of that? So let's think from backward. I'm inclined towards solving it from behind, because in the first case you have 2 choices whether you select it or not. But in the last case, if you are looking at just this part of the questions, forget about the rest. So there is nothing to the right of it. So only possibility is that you solve it, because there is if you leave it you will get 0 points. If you solve it you will get 5 points. So I can safely say that if I have till this part only, if I am coming from rightwards or end of the question paper, so if I just have till this point, maximum possible point is 5. Now I have solved till this point and I want to solve till this point incrementally, and our goal will be to reach till top first. So now here I have 2 choices. Either I solve it or not. So I will see that if I solve it, I cannot solve next question. In fact, the minimum possible brain power is 1. So if you solve any question, you can at least have to skip the next. It can be more, as in these cases. So now we are at, this is n minus 1th position, this is n minus 2th. So here, if we solve this, we cannot solve this. And if we skip this, we can solve this. So till this point, we will check maximum of, if we leave it and solve the next one, we get 5. If we solve it, we get 4 plus 0. We cannot solve next. So we will pick this one. So now for certainty, we know that till this point, I have the solution. And maximum possible from here to here is 5 points that can be earned. Now let's come here. Here again we have two possibilities. If we solve 3, if we get 3 points, then we cannot solve any other question. So this is one possibility. Next is I don't solve it but solve this one. Then I get 4 and 5. So so max of 3, 4 and 5. So how we are arriving it? So max of maybe if this is questions array, questions, let's say we are at index I, question I, and what is the point? First one, so 0. Max of this, and there are multiple cases. Questions I plus whatever is the brain power here. So this is the case where we solved it, so we get its point. But if we do not solve it, then we can take I plus 1 as 0. Next questions. So we have already solved till I plus 1. So we can safely see what is the maximum possible till here. So if we don't solve it, we can see what is the maximum here. So this is second. And additionally with these questions we can add, we have to skip this brain power, which is questions I1. This is the brain power, and plus 1. Because if it's let's say we are here, we solved this and brain power is 2, so we cannot solve this, we cannot solve this, we can solve this. So if this index is let's say 10, this is 11, this is 12, this is 13. So if brain power is 2, if we solve 10, then next we can solve is 13. So questions I1, which is brain power, plus 1, this index. So you see what I'm saying? If we are at some index I and we have this points and brain power, so we take maximum of P plus Pi plus B plus 1. That is, we skip some points here, and this is B, and this is Pi plus B plus 1. So this is the case when we solve this question, and the other possibility is Pi plus 1, next one. So we have to take maximum of these. So here what are these possibilities? So first case, when we solve it, we get 3 plus, if we add 3 to it, we will go out of it, this, so we get nothing. So maximum of 3, and what is Pi plus 1? So till I plus 1, maximum possible is 5. So again maximum is 5. So till this point also maximum is 5. So we can assign some value here. So maximum till here is 5, till here it's 5, till here it's 5. Now let's come to this point. Again think here. So if we solve it, we get 2 plus skip 2 steps, skip this, come here 5, and the other possibility is whatever was the solution for next step, I plus 1, which was 5. So maximum of these is 7. So till here now we have 7. Now let's come to the first. Here again, if we solve it, we get 1 plus skip next, come here, it's 5, and the other is just look the next one, which is 7. So maximum is 7. So till here it's 7. Now we have solved till beginning, and the maximum is 7. So what is the time complexity? We start from here and just do one iteration of this vector or list and return whatever is in the beginning. So the idea is that incrementally solve. So for the last element, what is the solution? For the last 2 elements, what is the maximum possible? For the last 3 elements, what is the maximum possible value? Last 4, and so on. And here it means for the complete list. So now let's code it. So this is the problem. So let's take the size in questions.size. So let's initialize this solution which we were calculating. Let's initialize everything with 0 and then run a loop. We will start from back, so n minus 1, I greater than equal to 0, minus I. So let's first initialize points I with whatever was the point. I0. Now if I plus current index plus questions I, we get ith question and 0. Not 0, I think 1. So this is the Brainpower. So second index is Brainpower. So I am trying to see that if I solve current question is I plus Brainpower plus 1, because we skip these many and then the next one, so plus 1 is added. If it's less than n, that is it does not cross the vector, then only we can add. If it crosses, then there are only two possibilities, current point or solution till next point. But if it does not go beyond the boundary, we have another possibility that points I equal to max of points I plus skip Brainpower points. So points I plus points, and the new index is I plus this same thing. That's why we calculated it, that this index is valid. So we included current point and we included point of after skipping brain points. And so this is one part from the slide, if you see. And the second was next solution till next point, which is simply points I plus 1. So whenever we are at I, we have already solved I plus 1. So we can take whatever its value, and that's the final value for I plus 1. So this was the case when we don't go beyond it. If we go beyond it, then we have to check maximum of so one case is the edge case, like if we are at last point, then I should be less than I minus 1. If you initialize this last value, then you don't even need to check this. You can simply write points I equal to max of points I plus 1, and finally return points 0. And let's run it and submit. See, the two test cases passed, and all the test cases are passing now. So I hope you understood it, and the logic was somewhat important to understand. Coding part is very trivial. So see you in the next video.